Hi everyone, today I'll be talking about Brønsted acid-base reactions. So a Brønsted acid is a substance that can donate a proton, and a Brønsted base is a substance that accepts a proton, typically from the Brønsted acid. So this is a general acid-base reaction mechanism, where the acid and the base react and the conjugate base and the conjugate acid form. Based on the strength of the acid and the base, the reaction may not be reversible. So a strong acid has a strong tendency to donate their proton, and it is 100% ionized in solution, and it results in a weak conjugate base. A strong base has a strong tendency to accept protons, and is 100% ionized in solution, and it results in the formation of the weak conjugate acid. So this table to the right just shows the relative strength of acid and bases, with increasing acid strength here and increasing base strength here. So these acid and bases undergo complete ionization, and which makes the reaction not reversible. So a conjugate base is formed when an acid loses a proton during an acid-base reaction. A strong acid will result in a weak conjugate base because a strong acid prefers to remain in its dissociated state. So the need for the strong acid to remain unprotonated means it has a low affinity of accepting a proton, making it a weak conjugate base. And let's remember the definition of a Brønsted base is a substance that accepts a proton, typically from the Brønsted acid. So if it has a low affinity of accepting a proton, it is a weak base. So a weak acid results in a strong conjugate base because a weak acid prefers its protonated state. So when it releases a proton, the remaining conjugate base has a strong need to get protonated, making it a strong conjugate base. And going back, if a substance has a strong affinity to accept a proton, it means it's a strong base. So a conjugate acid is formed when a base gains a proton during an acid-base reaction. A strong base results in a weak conjugate acid because a strong base has a strong affinity of gaining a proton because it prefers to be in its protonated state. Thus, it will not want to donate a proton, making it a weak conjugate acid. Going back to the definition of a Brønsted acid, it is a substance that wants to donate a proton. So if it does not want to, it means it is a weak acid. A weak base results in a strong conjugate acid because a weak base has a weak affinity of gaining a proton because it prefers to be in a non-protonated state. Thus, when it gains a proton, it will want to get rid of it, making it a strong acid. So a strong acid or base will completely dissociate, resulting in a non-reversible reaction, and a weak acid and base will partially dissociate, where the reaction is reversible. So let's do some example questions. So for the following reactions, identify the acid, the base, conjugate base, and conjugate acid. So let's remember that an acid will donate its proton, and a base will accept a proton. So let's looking at hydrogen fluoride here. It loses its proton. So this will be the acid, and this will be its conjugate base. And NaNH2 gains a proton. So this will be the base and its conjugate acid. So HCl loses its proton. So this will be the acid, and this will be its conjugate base. And NaOH will gain a proton, resulting in base and the conjugate acid. So for the following examples, we'll complete the following acid-base reactions and determine if the reaction fully dissociates or partially dissociates. So whether or not the reaction is reversible or non-reversible depends on the strength of the acid. So first we'll look at the strength of H2S in the chart, and it is an acid, but it does not undergo complete acid ionization. So that means that the reaction is reversible, and it'll donate its proton, and the base will accept it. And we must ensure that net charge is balanced, where the charge on the right-hand side matches the charge on the left-hand side. And we also know that a weak acid will not fully donate all its protons. And we can also verify this by looking at the strength of HS-. So it is a weak acid here, and it will not undergo ionization, meaning that the reaction will terminate here. So for the next reaction, we'll look at the strength of H2SO4. And it is a strong acid, and it'll undergo complete acid ionization, meaning that it will donate all its protons. So it is a non-reversible reaction, and the conjugate base is HO42-, and the hydronium ion is the conjugate acid. To ensure that the net charge is balanced, the charges on the right-hand side must be neutralized. So that means 2 hydronium ions will result, meaning that 2 waters must be used to neutralize the reaction. So summary is that Brønsted acid donates a proton, and once it does, the conjugate base remains. And a Brønsted base accepts a proton, and the conjugate acid remains. A strong acid will result in a weak conjugate base, and a weak acid will result in a strong conjugate base. And a strong base will result in a weak conjugate acid, and a weak base will result in a strong conjugate acid. Additional practice problems, including the examples done in this video and the answer key, are linked in the description box below. Thank you, and I'll see you guys next time.